This is Geometry Chapter 12, Section 8, in which we will be studying congruent and similar solids. Congruent solids are exactly what you think they are. They are solid shapes that are identical in every way. The angles match up, the edges, the faces, everything about them are identical. Similar solids have the same basic shapes and their ratios are equal. So the ratio of the heights is the same as the ratio of the edges or circumference or anything linear. And we kind of worked with this idea back in chapter 11 when you did the ratios and the square of the ratios when you dealt with area. The same idea is going to come back into play here in a minute for volumes. So the first thing they're going to do is ask us, are these similar, are they congruent, or are they neither? And we have two cylinders in this case. So that's already a positive thing. They're the same shapes. The height is 10. The height is 10. That's promising. The radius is 4. The radius is 4. That's promising. Everything about them is identical, so we say they're congruent. Notice they don't have to be facing the same direction. Okay, this cylinder is still the same size no matter how I turn it. Okay. Now let's look at these two cones. Okay, they're both cones, so at least they have a chance. Let's see if the ratios are the same. So I'm going to look at the ratio of the radii, 5 to 6, and the ratio of the slant heights, 12 to 14.4. Well, if I cross multiply 5 times 14.4, 12 times 6, let's see what we get. They're both 72. Since they're both 72, they are similar. And the scale factor, really you could use either one of these, 5 to 6 or 12 to 14.4. The 5 to 6 is simpler to write, so that's the one I would use. I guess technically there's nothing wrong with using that one. But typically we like to take the shortest way out we can get, so 5 to 6 is the choice I made. Now our first, last, and only theorem of chapter 12 deals with the idea of similar solids. If we know their scale factor is A to B, then their areas are in ratios of squared, A squared to B squared, like we talked about in chapter 11, and their volumes have a ratio of cubes, A cubed to B cubed. Okay. Volume is cubic units, so then the ratio would be cubed. So let's say we have a couple of similar cones with radii of 10 and 15 millimeters respectively. What's the ratio of the volume of the small cone to the volume of the large cone? Okay. We don't need to find the actual volumes. For one thing, we can't. We don't know heights. But the scale factor is 10 to 15, which reduces to 2 to 3. Volume, remember this theorem tells me volume means to work in cubes, so I need to cube both parts of the ratio. 2 cubed is 8, 3 cubed is 27, so the ratio of the volumes is 8 to 27. Fairly straightforward. Suppose we have a couple of similar prisms and we know their surface areas. I want to know the ratio of the heights. Well, we can get the ratio of surface areas 98 to 18, which I can reduce, they both divide by 2, gives me a 49 to 9 ratio. Now that's for areas. Areas are square units. So we need to take a square root to get down to linear units like height. Square root of 49 to 9 is the same as 7 to 3. One more problem to look at here. We're going to do one with volumes. We know the two volumes of the shapes. The height of the larger one is 10. Let's find the height of the smaller one. Well, first, let's do the ratio of the volumes. And it reduces to 27 to 64. Okay. Volumes are cubed, so we need to do the cube root of each one. Every calculator takes the cube root differently as far as how you enter it into the calculator, so you're probably going to need to ask, and I'll be happy to show you where your cube root is and how you use your calculator to get there. But we're going to take the cube root of each one. Cube root of 27 is 3, and the cube root of 64 is 4. Now we're in business because we know the ratio is 3 to 4. And the large cylinder is on bottom with the 4, so that's where we'll put the 10. A little cross multiplying and dividing, we find out that the height of the small cylinder is 7.5 inches. So we can work around this a couple of different ways. We can set things up in different kinds of ratios. We can do cube roots or square roots to get down to the basic scale factor, or we can square and cube to go forward to the bigger ratios. If you had questions along the way, hopefully you wrote those down. Bring them in with you, and we'll see you in class.